Hello, everyone. We're here to talk to you today about design quality control. You can see this first slide we have up shows a quick overview of the department's project delivery process. We go through a lot of stages to fully deliver a project in the department: planning, PD&E, design, procurement, construction, and operations. We're going to focus today on design side. And you kind of get an idea from that slide there. Design is a pretty major component of the whole cycle. And you can see there's quite a few elements that go into design quality control. Everything from final plans, QC plan, checklists, ERC, criteria. And those are just a few. There's obviously more than that. And all of that plays a role in design quality control. Okay, before we go too far, just wanted to run through a couple quick facts. First of all, you can see around 85% of FDOT's design projects are performed by consultants. In fiscal year 15-16, number of design consultant contracts executed totaled 927. You can see the breakdown by district listed there. At the same time, in fiscal year 15-16, 417 projects were led. All of this combined, higher percentage of work is being done by consultants. FDOT remains a decentralized organization, yet continues being more process-based, and projects are becoming less and less standard. We're doing more design build, complete streets, off systems, and as we all know, every day new initiatives come through. And with these drivers and large quantity, we obviously need quality. Okay, and this is just a quick overview of outline that we're going to talk about today. Obviously, as we said, design quality control. We're going to just do a quick overview just in general about quality control and quality assurance, or QC/QA. A little bit about tools that are used for quality control, phase submittals, and some successful strategies that we came across while putting this presentation together in regard to quality control. Okay, let's start out how a lot of things with the state start out with is statutes. Section 20.23. Florida statute requires quality assurance process. It requires central office to ensure quality performance of the districts and central office units that implement transportation programs. Basically, what this is saying, is that the department is required to have a quality assurance process. And section 334.048, Florida statutes, the intent of implementing accountability and monitoring systems to evaluate whether the department's goals are being accomplished. And obviously there's more to that, but that section 334 kind of outlines the number of parties that are responsible and play a role in responsibility and accountability of quality for the department. And it ranges from Transportation Commission, the Secretary, Central Office, all department managers, districts, and the Inspector General. So obviously, it's, as you see, hammer coming down, quality is the law. Okay, and secondly, getting down into the more detailed law that we deal with on projects, our project contracts, scope of work. Within the scope of work template that we advertise all our design contracts, if you read through section of project common tasks, you'll see a section called quality assurance, quality control. It is the intention of the department that design consultants, including their sub-consultants, are held responsible for their work, including plans review. Purpose of consultant plan reviews is to ensure that consultant plans follows plan preparation procedures outlined in the plan preparation manual. That state and federal design criteria are followed with the department concept, and that the consultant submittals are complete. And all sub-consultant document submittals shall be submitted by the sub-consultant directly to the consultant for their independent quality assurance, quality control review, and subsequent submittal to the department. What all this is saying is that when consultants are awarded projects with the department, part of the contract, part of their scope of work is quality control. That's the default part of any contract. And not just the prime consultant, but also the sub-consultants. And it also clearly outlines the hierarchy that any work produced by sub-consultants there should be a quality control procedure that it goes through the prime consultant. Now there's a lot more to it, but I just wanted to kind of give you an overview that, quality control, it's state law, and on top of that, it's in the contract. Okay, and a couple definitions I wanted to go over with you before we go too far. These are just a couple of the terms we'll be talking about today as they are in this presentation. One is quality assurance. This is one, I feel a lot of gets used in different terms a lot of times, but per the PPM, quality assurance is the planned, coordinated, and continued activities performed to measure processes against predetermined critical requirements. The objective of quality assurance is the continual improvement of the total delivery process to enhance quality, productivity, and user satisfaction. A couple keywords there is measure the process and continual improvements. Just keep that in mind. We'll get to that later on, but keep that in mind about quality assurance. And quality control. Quality control is the process performed to ensure conformance with valid requirements. This process includes quality planning, training, providing clear decisions and directions, constant supervision, immediate review of completed activities for accuracy and completeness, and documenting all decisions, assumptions, and recommendations. Now, again, kind of the key word here is quality control is the process performed. Again, we'll come back to that later, but from looking at that, I think you see the difference between quality assurance and quality control. And a quality control plan. A quality control plan is a comprehensive, well-defined, written set of procedures and activities aimed at delivering products that meet or exceed a customer's expectations as expressed in contract documents and other published sources. Quality control plan will identify the organization or individuals responsible for quality control and the specific procedures used to ensure delivery of a quality product. Quality control plan will also detail quality control measures and the method of accountability and required documentation. And likewise, in addition to quality control plan, you often hear the term project-specific quality control plan. Very similar, but project-specific is a quality control plan for a specific project which details the procedures to be used to ensure quality deliverables. The procedures should ensure that the plans and other design documents are substantially free of errors and the project is functional, constructible, and biddable. And kind of just wanted to run through like those first two terms we went over, quality assurance, quality control in this slide here. Again, I have highlighted key words for each one. Quality assurance is to measure the process. Quality control is the process performed. And kind of another way that I often like to think about it is throwing in another term that you'll hear me talk about called design acceptance. Design acceptance is a recognition of completion based on quality control measures. In other words, quality control leads up to design acceptance, which leads to your design being complete, whereas quality assurance leads to continuous improvement. So when you're reviewing a document or a set of plans, think about, are you reviewing it and making comments for the purpose of completing that project, getting design acceptance, or are you reviewing it for the purpose of continuous improvement? If you're doing it for future improvement, continuous improvement, you're doing quality assurance, not quality control. And kind of at this slide, you see kind of a basic process of quality control. Quality control for design is a very simple mechanism, really. You kind of see up at the top left-hand corner, a little diagram. Basically, for every quality control function, you have inputs, and I kind of summarized some of the main inputs. There's obviously more, but you'll most usually fall within those categories. You have your people, decisions, design decisions that already have been made, objectives, your project objectives, which includes things like your scope, your purpose and need, information, general information that's available to everyone about the project, and then your product as it stands at that point. I mean, don't forget, quality control doesn't build a product. There has to be a product in place to perform quality control on it, which in this case, product is generally our plans and specs. It can also include reports and other documents, but it's usually plans and specs. And you will typically have some kind of a quality control process, which leads to, the outputs. And as you notice, the outputs are exactly the same as your inputs, just with a slightly refined, because as we said again, quality control doesn't build the product. The product has to be in place to perform quality control on it. And you have that constant loop taking place, of QC feedback. If there's something major that needs to be revisited, you have this loop of QC feedback, which you can kind of see that a little bit better outlined in the flow diagram below. You kind of have, we can start from the beginning there and just go through that. Obviously you have a product, plans and specs in place that have to go through some kind of check or review. If it's good, it makes it to the output without any QC feedback. If it's bad, there's something either unacceptable or could be improved. Bad doesn't necessarily mean completely unacceptable, but it could also mean there's room for improvement. You then have to go through some kind of disposition process. Usually the quality control itself doesn't tell you the corrective action. There's often a second step of a disposition, another meeting or additional communication, where you have to determine, do you either delete that element where the concern arrived from? Do you make a minor revision, which, as you can see, it kind of goes back on the good path with little to no feedback? Or is there a major revision where then it goes through basically another check review cycle, where you can kind of see that illustrated at the top left-hand corner of that QC feedback loop. And that's basically the primary process that we go through with every quality control mechanism in place. And of course, what makes design really interesting is it happens multiple times for the same product throughout the life of a project. And even further down at the downstream section, there can be sometimes feedback that takes you back to the beginning. And to make it back to that downstream, you sometimes have to go through the intermediate steps all over again. That's kind of the interesting, unique part about design, of the way we do design in the department. And this is just another quick overview of how we spoke about, whenever you're thinking quality control, you think about it in terms of your inputs, your tools and processes, and then your outputs. And like I said, the outputs are basically dependent on your inputs and tools and processes. And I have there listed some items that contribute to quality control: communication, meetings, QC plans, ERC, checklists, manuals and standards. I have value engineering, and I'll just say, although value engineering itself is not specifically targeted at quality control, it often has the outcome of helping quality control throughout the life of your project. Phase submittals, cost estimates, constructability reviews, those are just to name a few. And we're going to try to talk to you today about many of those items you see listed there. But, there's more. You have quality control, and you have phase submittals and more quality control. And kind of threw that in there to kind of highlight, what a phase submittal represents throughout that process. Because you kind of see throughout this diagram I have here, you see that quality control diagram taking place multiple times, multiple channels of work happening, each one going through multiple iterations of quality control. And you see those black arrows kind of indicating, QC feedback or coordination taking place with each channel of quality control. There's a lot of communication feedback, and you notice, that feedback, as we spoke about, can cause you to kind of back up a couple times and before you can move forward again, to back up and, go through the process over again. And that's kind of now obviously you can't do that forever, and that really is the main reason we have project phase submittals. Project phase submittals kind of represents a level of completion that you shouldn't have to go back again. When you're setting up a project, you want to set up your project with enough phase submittals and enough time in between each phase submittal so that you have enough of these iterations of quality control that once you reach a phase submittal, you don't have to go back. Essentially, like as you can see here, not good. If you have to do that, it sometimes means probably in the future you'd want a little bit more time between those two phase submittals for that type of a project, or to have additional channels of quality control for your product. And kind of as you can see, it starts to get simpler as you get closer to the end, towards design acceptance. You see those black arrows, the feedback coordination starts to become less and less. And a key thing is between your last phase submittal and design acceptance, you should only have one level of quality control left in place. There should only have to be one iteration. Everything should get reviewed once and be ready. If it's going through multiple iterations between your last submittal and your design acceptance, it's sometimes, again, that's something to keep in mind for your next project, that to either space it out or to add another phase submittal or another quality control mechanism in between your design acceptance. Well-run project should only have one iteration before your final design acceptance. Okay, and obviously one of the biggest inputs in all this is people. And for people to function properly, there has to be roles and responsibilities. I'm just going to run through a couple quick roles that are involved in quality control. There's more than this, and we'll go through more, but these are some of the main ones that we'll probably be repeating throughout the presentation. One is the FDOT project manager, and obviously most of you on the line probably are project managers, and as you know, often feels like you really are the focal point of quality control, because the FDOT project manager is responsible for the planning, coordination, and controlling of a project from inception to completion, meeting the project's requirements and ensuring that each project is completed on time, within budget, and to required quality standards. The FDOT PM should be part of the process to review plans for quality. FDOT PM acts as an intermediary between consultant project manager and reviewers, and ensures that all phase reviews have been completed, all comments have been satisfactorily addressed, and that all forms and checklists have been completed by the appropriate personnel. FDOT PM is ultimately responsible for each project's adherence to quality control plan. So, basically you can see the FDOT PM has a stake in it pretty much through every stage of the quality control process. That's probably one of the biggest things to take away. The DOT PM is really with it throughout the life of the project at every stage of the project. And you have, of course, the engineer of record, an individual responsible for the design of a contract set of plans. This individual is a licensed professional engineer. The engineer of record signs and seals final contract plans and specifications. You know, you may have more than one EOR who may be responsible for different components of the project. And of course, you have your designers, an individual directly responsible for the development of design calculations, drawings, specifications, and contract documents related to a specific design with a level of technical skill and experience commensurate with the complexity of the project. And a few others, you know, as you know, there's a lot of people involved in quality control. Within quality control plans, you'll often see a role labeled as a checker or a QC reviewer. Those are typically very similar. They're typically an individual responsible for performing a full technical review of design calculations, drawings, specifications, and contract documents. And you will often see the term reviewers, a little bit different than the QC reviewer. Reviewers are individuals responsible for checking that proper procedures have been followed. The reviewer must not have been directly involved in the performance of the original process. Again, you can see like the checker or QC reviewer at a little bit more technical level, where the reviewers are more looking at the proper procedures. You have district final plans. You know, this is a resource to assist in-house staff and consultants in the development of construction specifications and estimates to ensure projects successfully meet critical production dates. You know, final plans helps coordinate the quality control challenges with central office staff, aids in the preparation of policies and procedures. And likewise to final plans, central office, another resource to support the districts and design community in the delivery of quality and cost-effective plans, specifications, and estimate packages through comprehensive quality assurance and process reviews, and through the management and administration of programs that provide support in the development of projects. You remember us talking earlier about quality assurance, and that kind of really is, obviously districts perform quality assurance as well, but that really is a key role of central office, is to perform quality assurance and try to help provide that support for continuous improvement of projects and through continuous improvement of process. And you kind of see laid out here kind of how all those roles fit together. You know, there is a map to it, you could say. You can see at the left, you know, a product typically starts with the designer, and you can see this triangle between designer, checker, and EOR. There's typically this type of review triangle, or you know, some back and forth this way. But there's typically a level of interaction between these three personnel before it then gets passed on to FDOT project manager. FDOT project manager typically has two reviewer resources that a project has to go through. There's final design review, which is typically through our ERC, which we'll talk about later, and things of initial design review, which is some of the more technical review that it goes through. And you know, you can kind of see this whole loop here is again another cycle that quality control has to satisfy. As we spoke about that QC feedback loop, you'll see that loop taking place with these main players here. And you kind of see at the top, just above the FDOT project manager, is FDOT support services, because there are numerous personnel, as we spoke about earlier, that are there to provide support to the FDOT project manager and to the entire design team, although they may not be directly involved in reviewing the plans. This can be both the district and central office, any resources that are available, but not necessarily reviewing the plans. And you also see FDOT final plans office. Each district has a final plans, and you can see the key role that the final plans office plays in being that bridge between quality control and design acceptance, where it then gets moved on to FDOT central office final plans, where now project is more along those lines of design acceptance, you know, or completeness, which we'll talk about more later. You see also above engineer of record, you have on some projects, we do what's called a peer review. A peer review is almost essentially a repeat of this whole triangle taking place again, signed and sealed by another engineer. And you also see both within the realm of quality control and within design acceptance, you have quality assurance taking place. Quality assurance is always taking place throughout the entire process, but as you see, it's not directly tied to anything. Quality assurance reviews shouldn't have any impact on the project schedule or progression of the project. They're continuously taking place for continuous improvement, but should not impact the progression of a project, unlike quality control. And here you kind of see just a sample of how that loop typically plays out on a lot of projects. Took an example of a typical section. Typical section criteria is established based on project scope, standards, and other customer input. It goes to the designer, as we saw in that last diagram. The designer produces a typical section and reviews it, that it meets all established inputs. Again, quality control, highly base the outputs based on the input and the quality control. It moves on then to the checker or the QC reviewer, as we said. And the checker reviews that it meets all criteria and overall quality. If it passes that, it will move on to the EOR to verify it meets all criteria and still meets the scope, meets all commitments and overall quality. Then moves on FDOT PM, who reviews if the submittal is complete to the department's requirements and still meets the original project objectives. And if it passes that, obviously there's often an FDOT review, an internal technical review, FDOT review that reviews it meets critical criteria and meets department requirements. And if it passes through that, you could get to the acceptance of that typical section, which is essentially typical section is processed, it's signed and sealed, and distributed to all parties. And if you can make it to the output, you now have an approved typical section incorporated into the project. And obviously, as we said earlier, what makes the design process interesting is how we often go through this loop of QC feedback. When it reaches the PM, the outcome of the PM's QC review could be that, that wasn't part of the original scope, or that we had an original commitment with a local agency that wasn't incorporated into the typical section, or likewise, it might. And obviously, if it goes through that loop, it has to pass through each of these stages to make it back again. And likewise, if it gets to the FDOT review, at that stage, it's often, there could be that it doesn't fully meet the department's criteria. There could have been some, at the earlier stage, a lot of people might have been very focused on the scope, the objectives, that they forgot a few of the very detailed aspects of the criteria that needs to be met, which can often result in, that loop of it going back through some other iteration where it makes it back to design acceptance. But through each iteration, the inputs are typically enhanced. And that's something to keep in mind. It's having the inputs enhanced to the highest level possible the first time can help reduce the number of iterations that a project has to go through. But every time it goes through that, it does get enhanced. So it, as we all know, it happens either long way or a short way. And to make all that happen, QC feedback requires communication. You have to determine the most effective way to communicate quality control feedback. You have to use appropriate form of communication. A couple things about communication: you should need to address it to someone. You need to name the person responsible for communication. You often have to provide desired response timeframes. You have to target the specific audience. Like you see that QC feedback loop there. It doesn't always have to go to the very beginning of that chain. Sometimes there's another level that it needs to be directed to. Maybe it's something It doesn't have to go back to the designer. Maybe the FDOT PM, after it going through the FDOT review, can address something. It might be something that it can be addressed at a more intermediate level. It doesn't always have to go back to the very beginning. And you kind of see at the right here, there's a lot of different types of communication: face-to-face meetings, conference calls, emails, and really the key is picking the appropriate form of communication. One of the key types of communication and QC processes that we use in the department are meetings. And I just wanted to kind of go over a couple tips, meeting tips that can make a meeting a more effective quality control process. One is, obviously, you've heard this many times: don't meet if you don't need to. That all goes back to what we said in the previous slide of selecting the appropriate form of communication. Avoid a meeting if the same information could be covered in a memo. I mean, is this like even that the earlier slide where we spoke about, is this a disposition or is this just a comment, an FYI type comment? The product is good, but it's more of an FYI for something in the future. If it's more of that, then obviously email or other form of communication is sufficient. If it's something that requires a disposition, then maybe a meeting is more appropriate. Obviously, set objectives for the meeting. The more set your objectives, the more focused your agenda will be. Provide an agenda and information beforehand. Allow participants an opportunity to prepare for the meeting. Prepare meeting material, handouts, roll plots, and other information. Even if it was provided ahead of time, it should still be available at the meeting. It kind of goes to what we said, earlier, the inputs, providing the information beforehand to the people, the information, giving it to the people strengthens those two inputs going into it. And having the material available during the process of while the disposition is taking place, that needs to happen too. Assign action items. Now, obviously, the whole point is to get to these outputs. And so the action items of what that output, what that QC feedback is, needs to be very clear. And also, when another very common form of QC feedback and communication is email. Email has become an effective way to quickly communicate concerns, comments, or feedback on the quality of a design or the design process. Obviously, email is often favored because it allows for on-the-fly feedback about quality control on a regular basis. It provides documentation, which is very important. Documentation of the concern or questions that took place, as well as responses from the other design professionals. It allows inclusion of support offices. As said before, there are other personnel that might not have been directly responsible in reviewing that product, reviewing the plans, but they still need to be kept informed of what's happening and what the disposition is going to be. So it keeps support offices in the quality conversation without having to hold formal meeting or conference call. But the key big thing about email is that note at the bottom: email is not a replacement for discussions that will require a lot of back and forth that would better be handled in a more formal manner. Like I said, if it's more of a disposition, you probably do need a meeting or a phone call. If it's information or direction, then maybe email can be appropriate. And with critical communication at major milestones, request certification. This has become a common practice throughout the department. Like one of the major milestones we spoke about is often phase submittals. Prior to reaching a phase submit, like we said before, a phase submittal is a milestone where you don't want to go back. You're trying to reach a certain point. So you're looking for a little bit higher safety factor that quality control has taken place. And the tool we typically use to give us that additional safety factor is often certification. Obviously, certification is the process of officially attesting or confirming to have meeting specified requirements or standards. And we usually have multiple levels of certification leading up to those milestones. Typical process usually it is certification from the EOR to FDOT PM, and from FDOT TM to the reviewers. Remember, though, certification is not a checklist. Quality control checklists should be much more detailed and in-depth than a certification. A certification is more of a summary of meeting specified requirements. But there obviously should be a lot more requirements that went through the quality control process. And I kind of threw this slide in here. I just wanted to kind of give everyone, a quick comparison, at least what I've always felt the big difference between design quality control and construction quality control. Design quality control really is a much simpler model, but it undergoes multiple iterations with multiple reviewers with different technical skills until it is optimized to satisfactory level. That QC feedback loop of having to go through the process multiple times, that's kind of what makes design a little bit unique from construction. Construction quality control has more parts, but has a fixed, typically one iteration to achieve pass or fail. But in both, one thing is always the same: quality assurance leading up to continuous improvement. In both design and construction, there is always quality assurance taking place in the background. Training. The importance of training. Training, quality in design requires us to have quality people trained well in core competencies. As said again, one of the key inputs throughout the whole quality control model is people. So making sure we have people properly trained is very important. And another thing to clarify about training, a lot of people think about training as being a training course or a CBT that you go to, but training is more than that. Training is the transfer of skills, knowledge, or experience. And there are many opportunities for training taking place every day. There are lessons learned that we share with each other from previous projects, or they are documented in some form of a knowledge base. There are the traditional training courses that a lot of people often think of. Project experience. As you're going through a project, you're gaining experience. That really is training. Meetings and communication. All of that, you learn something. All of this is, as we said, the transfer of skills, knowledge, and experience. It's training. And one of the key parts of training is lessons learned. It's important to take the time to review lessons learned. Review what went well and what did not go well on previous projects. And you can kind of see at the bottom there, that quick diagram, it's important to do this both at the beginning and at the end of a project. At the beginning, identify what went well on previous projects and what didn't go so well on previous projects. And so you can incorporate those lessons into your project-specific QC plan. And as you come up to the end, you kind of review this project. What did you learn? Every project is unique. There was always a lesson learned. And a key reason to have this meeting again with your project team at the end is because, as you see that diagram, typically the project team splits at the end. At the completion of a project, consultants go one way, the FDOT goes another, and sometimes within the FDOT there's a team that kind of breaks apart until another project comes. And it's important. There's a lot of knowledge that's only realized while the team is together. So it's important to capture that knowledge, capture those lessons learned while the team is together. So as you can see, the FDOT can gain those lessons learned into the FDOT lessons learned. It is important to both apply past lessons learned and develop new lessons learned. And training, again, this kind of gets back into what we typically think about training as training courses. Central office is the resource, is probably our biggest resource that is mandated to provide training. This includes both development and delivery. Central office provides needed training, which is reported to central office by each district, and central office conducts training courses as requested. Central office provides several training related to project management and quality. We have some of the courses that we went through some of the courses that's in Learning Curve and listed them there that that are beneficial for project management and quality. You can take the time to go through that, because one of the key resources we have right now is indeed Learning Curve. Learning Curve is a big resource that makes it a lot easier for individuals to go through those courses on your own, at your own pace, on your own time. Other courses are available through Learning Curve that we might not have listed there, but Learning Curve also has a search tool. You can easily type in either quality, or if it's something more technical, roadside safety, type in, and Learning Curve is a very powerful tool to pull up a lot of the training resources that are available. Another resource, is manuals and handbooks. A lot of people, to digest something, they have to read it themselves instead of having it lectured to them. And these are some of the critical manuals that we have within the department that outline a lot of the guidance for quality control. Obviously, the plan preparation manual, which contains all of our design criteria and gives us the outline and framework of our project delivery process. The project management handbook, a lot of guidance in the handbook about how to conduct your project and how to conduct yourself as well. CPAM, the Construction Project Administration Manual. There's actually a lot of things within the CPAM that pertain to project reviews for design, about reviewing for constructability. There are certain sections in there specifically about how to review design projects for constructability. And the FDOT CAD manual. Obviously, the product we're developing in design is the plan, so not after, the final roadway gets built during construction, but our main product really is the plan. And a lot of the quality of the plans comes from the consistency and standards of FDOT CAD manual. Quality control plans. This is probably the mother of, one of the most fundamental tools of quality control is your quality control plan. As we spoke about earlier, there are basically two quality control plans on a project. There's the quality control plan, which really is the district quality control plan, which is developed by the district ahead of the project. It should be referenced in the scope and thus becomes a requirement to be met through the life of a project. And your project-specific quality control plan. The project-specific quality control plan is developed by the design team during the project and thus should be treated as a living document agreed to by all and should be continuously updated to match the needs of the project. And to me, that's really the big difference of how to use the two and how to make sure appropriate material is in each one. Your district quality control plan is really your fixed requirements that would apply to any project. And your district quality control plan is essentially part of your contract with your design contract, part of your scope. The fixed requirement. But the project-specific quality control plan really is more of a living document. There are times throughout a project, you might need to perform an additional phase review, and you need to adjust your quality control plan to incorporate that. Or a project is accelerated, and you need to maybe combine your constructability, biddability, your phase 2 and phase 3 into one phase review, and you got to retweak your quality control plan to make sure that's properly being taken into account. So, the key is, key message of this slide here is, your project specific should be a living document. It should be, continuously updated throughout the project, and your district should be more of your fixed requirements. And you kind of see that reiterated in this slide here. Again, QC plans work, but they have to fit together. Before you write, your project-specific QC plan, know what's in your district QC plan, because the two have to work together. There are sometimes required checklists or required reviews in the district QC plan that they want all projects to follow. Your project QC plan has to fit into that. That's something to think about with the district QC plan. You don't want it always to be too rigid. Also, should leave enough room for the project QC plan to adjust to the specific project needs. A couple key points I have highlighted there, talk about like the district quality control plan should identify organization, responsibility, and accountability used to perform and document overall quality control, which mainly is talking more about the reviews, the phase submittal reviews, and a project-specific quality control plan. Obviously addresses project-specific scope of service, and it has to be agreed to by all, as we said earlier. It has to be approved by the project manager or the district design engineer as appropriate. So it's something both the consultant should be communicating with his DOT project manager with, so both know what the quality control process of the project is. And again, going back to the scope of work. In our project scope of work, again, under common tasks, as I said, that section of quality control, there's a lot listed there. These are some of the key highlights that I found. There's obviously more there, but these are some of the key highlights. The consultant shall provide a quality control plan that describes the procedures to be utilized to verify, independently check, and review all maps, designs, drawing specifications. The consultant shall describe how the checking and review process are to be documented, and the consultant shall submit the quality control plan for approval within 20 business days, written notice to proceed, and it shall be signed by the consultant's project manager and the consultant's QC manager. That's a role we didn't talk about earlier, but that's a critical role. On every project, there should be a consultant QC manager. The names of the consultant staff that will perform the quality control reviews, and the quality control reviewer shall be a licensed professional engineer, fully pre-qualified in the work type being reviewed. Just kind of quickly summarize that, is that obviously the project-specific quality control plan needs to outline procedures to be utilized to verify, independently check, and review. The project-specific quality control plan needs to outline process of documenting that review. The initial quality control plan has to be submitted within the first 20 days of written notice to proceed. As we said before, it can be and should be amended throughout the life of a project as agreed to by all parties, but it needs to have a starting point within the first 20 days. There has to be a role for consultant QC manager. That should be a key role within the framework of that QC plan. And the quality control reviewers shall be Florida licensed professional engineers qualified in the work type being reviewed. Like I said, there's obviously more to it, but those are some of the key highlights from that. And this is kind of summarizing all that combined. Obviously you have your district quality control plan, which should outline things such as staff organization within the district, staff performing the quality control, staff accountability to quality control, how is the quality control being documented, district requirements for project-specific quality control plan, and you have your project-specific quality control plan. Again, some of the things, procedures to verify, procedures to check, how the review is documented, staff performing each function, QC manager, QC reviewers, project manager. And I kind of have highlighted there, usually your district QC plan is a little bit more focused on the phase submittal requirements and the phase submittal process, whereas your project-specific QC plan more talks about the number and the schedule of phase submittals and developing the inputs into those phase submittals. And critical areas to be monitored. FDOT.ppm lists the following critical areas to be monitored for quality. And this is just kind of a little bit of guidance of how you might want to also break up a quality control plan. You might into initial engineering design, which initial engineering design is essentially your technical design elements, such as calculations and reports. Your initial Engineering design requires more iterations often. There's usually more technical review with more opportunity built into the process for QC feedback to develop and improve the product. Usually when you're into your final engineering design, now your final engineering design is more about your actual contract documents that will be let for construction. This includes elements such as plans, specs, and agreements. It requires a more streamlined process with a mix of technical, contractual, and constructible reviews, and update engineering design, amending either of the two requirements. And I mean, don't take these two flowcharts at the side too literally, but just to give you an idea, you know, an initial engineering QC process should be some kind of a little bit more of an iterative process. There should be a lot more time to go through a few revolutions of iterations of QC to make sure it's fully optimized. Where your final engineering QC might involve more people, but is usually a more streamlined process going through it. You're trying to go through it once, you know, compared to initial. You know, they're different. So it usually is good practice to have different process within the QC plan for initial and for final engineering. Quality control audit. You know, the main task of a quality control audit is to judge the effectiveness of the quality control plan, determine if it has been implemented, and provide guidance for improving quality control. You know, some quality control plans, they really look good on paper. They were nicely formatted and everything, but, you know, is what's happening on the left going on or what's happening on the right? You know, so it doesn't hurt for the department to perform quality control audits on consultants once in a while. There's no real set process in place how to do these audits, but just a few things you should be thinking about when you're performing an audit and reviewing consultant's quality control plan. You know, are documented checks and reviews available? As we said earlier, within the scope, the quality control process being documented is a key requirement. You know, general organization. Again, do you kind of see what you see on the left, or do you see what you see on the right? And when we talk about general organization, we're talking about both paper and electronic. You know, their hard copies that they kept for documentation should be neatly organized. And likewise, it doesn't hurt to, you know, ask them to show you their server. How are their files organized on their computer? Are they easy to find something that you needed? And is there, even to a certain degree, not a requirement, but good practice to have backup, you know, a backup for their server in place to recover data at any time? All of that is quality control, both paper and electronic in this day and age. You know, and just in general, are steps in the QC plan being followed and documented? Are they doing what they said they would do? Are the people and roles in the QC plan the same, or have personnel changed? I mean, people change all the time. A lot of people get new opportunities and move on. This is one of the main reasons I spoke earlier about the quality control plan being a living document. One of the key things that do change throughout the life of a project are the people. It's very rare to start a project and finish it with the exact same design team that it started with. Whenever the people change and the roles change, that should be updated in the QC plan and communicated to the department. Consultant grading, you know, this is part of that feedback we spoke about. You know, effective consultant evaluations allows for performance feedback and management in an ongoing process of communication between the FDOT project manager and the consultant. Effective evaluations require setting objectives, fair expectations, continuous feedback, and acting on that feedback. You kind of see, you know, just it's another process. It's a way to communicate whether work in general is, as we said, the earlier flow chart, good, bad, the process need to be revised? Major revision or a minor revision? You know, or obviously we prefer the A+, but sometimes the feedback is something that needs improvement. That's not always a bad thing, and you know, it doesn't hurt. Sometimes consultants want feedback, and they want to know before it affects them as well. You know, consultant grades, again, developing performance goals and objectives. You know, performance expectations should be clear, brief, attainable, and measurable. And as you know, our grading system is expressed in terms of these six points here: quality, quantity, timeliness, effective use of resources, manner of performance, and method of performing. You should talk about these things with your consultant before you start a project, so everyone's on the same page with the expectations. You know, and but like any type of QC feedback and communication, as we spoke earlier, to choose the appropriate form of communication, use caution when using grading as well. Inappropriate grading can cause a breakdown of teamwork, can confuse those being graded, and you know, kind of can force those being graded to focus on the short term of just getting the project done rather than getting it done to a high level of quality. So you want to be careful about using grading the right way. And kind of moving on, I wanted to go over what, you know, is often considered the quality control myth. You know, and that myth is often, it's a straight line, good or no good. My design falls within range of all criteria and meets all checklists, thus no further review or quality control should be performed. And can anyone tell me, is that a fact or a myth? Well, the answer is it's a myth. You know, the reality is it's a curve. It's somewhere within the criteria limits. You know, there is some place you reach an optimum benefit or it's optimum quality. You know, I'm showing it in this slide in the middle, but it's not always the middle. It's more sometimes skewed one way or another. And you know, as you can see here, just you might be somewhere on the curve and within the criteria, but a design meeting criteria still has opportunity to improve, to reach, you know, a little bit more of an optimum point of a higher level of quality. You know, so is it good or no good? You know, many times the QC feedback is really about that, optimizing the product, about optimizing net benefit or value, which can result in additional iterations or submittals. So one of the things that kind of helps us with this whole process of avoiding these iterations, I feel, is value engineering. You know, as I said earlier, value engineering is not in itself a quality control tool, but it can play a very beneficial role in a quality control, in your project's entire quality control process. You know, well-run value engineering process can help optimize value to meet project objectives, thus improving quality. You know, although it may seem like an additional step, if performed at the right time, it can actually reduce future iterations of quality control feedback. These feedback loops you're seeing here, you know, if a well-run value engineering process was conducted early on, and you have a little bit better look out that you've optimized your design, it can often avoid some of these QC feedbacks that take place later, which really are often about optimizing benefit and value. And of course, you know, when does it end? Because nothing is for free. You know, review comments cost money, meetings cost money, going back or redesigning costs money. So this is just to give you an idea. You know, like review comments, average cost of review comments is usually $200 per comment, according to the FDOT Project Management Handbook. Also, within FDOT Project Management Handbook, it's stated that there's usually an average of 180 comments on average per review. And I don't know about you, but a lot of the projects I've worked on, there's often a lot more than 180. You know, but just taking 180 comments with 2 reviews, $200 per comment, you know, already it comes out to $72,000. And the review comments aren't the only cost of quality control, as we spoke about average consultant cost for a value engineering study is often around $50,000. 2% of design fee is for coordination. A big chunk of that coordination is for quality control. 5% of the design fee is specifically for quality control. And meeting time is often paid as maximum limiting amount, which sometimes can make another 5%. I mean, all in all, what we're trying to say is it does cost money. And as we said before, that kind of usually brings you to this type of a curve where, initially you definitely have to put in an investment and you will get a return. You will get a better product. It takes a little bit of initial investment to see the results, but QC is worth it in the beginning. But you obviously do get to a point where, it's kind of I sometimes term it analysis paralysis, where you're reviewing it, you're never able to really make everyone happy, and you feel like the project is going nowhere, which sometimes take you into this negative territory of what I call a lesson learned for future projects. Usually the optimum point you want to try to target is like just over the hump, a little bit conservative. And, that's an important role the DOT PM has to play kind of to control that, to make sure enough quality control is taking place to get you over the hump, but to recognize, is additional reviews, is it really contributing? Are we achieving anything? If you start to feel you're getting into that phase of, like I called analysis paralysis, it might give you an indication you're kind of on the other side of that hump or getting close to it. Practical design. Again, practical design, similar to value engineering, is not specifically a quality control tool, but it can have that effect. So you got to keep everything in mind when you're thinking quality control. And one thing is practical design. Practical design offers a way to achieve the same quality optimizations as value engineering without the lengthy process or cost. Practical design is not a formal process, but a project approach that continues throughout the design of the project. Kind of as you see on the bottom here, the whole idea, what you're trying to do with practical design is really keep people and objectives focused on the purpose and need, but understand and apply flexibility in the design. Again, trying to keep people, the inputs refined, and keeping the objectives nicely refined, keeping them focused on the purpose and need. And, also there's a lot of guidance and checklists in the practical design handbook to help get people started with that. Effective practical design strategies include an understanding that each project is unique and solutions are not one size fits all. Okay, quality control. I think you all remember this little diagram outlining different roles of personnel involved in QC. And you see outlined there a key role, between the engineer of record, FDOT project managers, and, kind of your final design review. This is the point where there's a lot of people looking at, a lot of people reviewing projects simultaneously. And obviously with something like this, email can be overwhelming and individual meetings can be time consuming. As you can see that little picture on the right, if you try to perform a review like this with email alone, you'll feel like you're going below the water, basically. It's a lot of information to manage. So what we have is ERC to the rescue, and the beauty of ERC is it's simple to use. Anyone can access it through the internet, allows for easy distribution and tracking of review. Documentation, as we said, is a requirement of any QC process, allows sharing of documents, archives comments and response for reference. Everything that took place is there in case you have to revisit it. Allows interaction without face-to-face meetings. Sends email notices for new entries, due dates, reminders, late comments, and response notifications. And, I think this slide here really highlights the big beauty of ERC, and that's that neither the reviewers, the EORs, or the FDOT project manager is the middleman. ERC really is acting as the middleman and processing all that to all these different parties in an organized manner. And obviously, the process. Multiple reviewers make comments, submit comments to the project manager or to the EOR. Multiple EORs respond to comments, submit them back to the project manager or to the review team. And the FDOT project manager accepts and closes the comments or tries to resolve them, coordinates meetings or field reviews if needed to resolve the comments. And as you see, you have on the side connected to the FDOT, as we said, maybe not reviewing the plans themselves within ERC, but you always have FDOT support services assisting the FDOT project manager from either the district or central office. ERC, big part of inputs, as we said, ERC really becomes your QC process right here. And big inputs that go into ERC is your staff assignment, the people, what people are going to be reviewing. That needs to be carefully thought up. The project information, there has to be all information about the project available. It doesn't hurt to put more information besides just the plans that are being reviewed. Sometimes reviewers need additional information about possibly meeting minutes that took place, of why a design is the way it is, of certain commitments that took place already, and loading documents. Beautiful thing, you can always upload more information to ERC if people need it. And obviously all that, the output of all that is creating comments, responding to comments, and resolving comments. This is the staff assignment page of ERC. Angel, can you talk a little bit more about user functions of
in the ERC staff assignment? We have two ways to doing it. We can select for a default list that we pick in one shot, multiple reviewers, or we can select them one by one. One particular thing about ERC that only assigned individual will be able to see attached document. This is done for security purpose. We have plans and bridges that we don't want everybody else to see them unless they have to. Actually, the due date is set for. You have to respond before the due date. If you run after the due date, you have to request for an extension. When you respond to comments, you can add documents to reinforce your point. Comments can be created, saved, later submitted, or they can be submitted at once. And you can arrange them by categories.
I think the beauty of this system right here of ERC is, how we spoke about the importance of communication. Right here, it kind of shows you how ERC communicates with you. It's a very simple communication: green, yellow, red, blue. Green indicates that the due date is more than 1 week away. Yellow indicates that the due date is within 1 week. And red indicates that the due date has passed. And blue indicates that the due date has passed and there's nothing assigned for action. So, again, this is one of the, as we spoke about, part of the beauty of ERC is that now ERC is the middleman, and it simplifies the communication to all parties with these 3 simple commands: green, yellow, red, and blue.
Okay, now we're moving to the when you're gonna create comment. This is what you're gonna be seeing. When you see the create comments link, If you see grayed out, that means either the due date has passed, or you haven't, or you assigned to create comments. And on the lower part, you see the categories that you're going to assign your responses to, your comments to.
And basically, you can see with creating comments, this basically takes you to your first iteration of, quality control. As we started out, ERC process with staff assignment, project information, loading comments. It passes through that review, ERC to the reviewers, and out comes organized comments per category and per reviewer. And that's a key benefit of ERC is the fact that they're organized comments by category and by reviewer.
Okay, when responding to comments, the lead designer has a couple of options. They can agree with the comments, they can respond to the comment, or they can assign it to somebody else to handle that assignment. On the resolve comments, you have the in-house PM. The option that they have, they can resolve it. The rescind meaning is that you don't agree with the comment, you want to send it back to them for them to edit and then submit it again, you rescind the comment. They can reopen the comment.
Yeah, and as you can see, you can kind of see how this all plays out at the bottom there, where it passes from, you start out with your staff, starting all the way on the left, you start out with your staff assignment, project information, and loading documents. You can see it passes from reviewers to the EOR designers, back to the reviewers, back to the EOR designers. And this kind of takes us to, as we said before, about, sometimes the target is just over the hump, but still in positive territory. And, this function here, resolve, rescind, reopen, this is the key function of the FDOT PM, the key role the FDOT PM has within ERC. That's why it's very important for the DOT project manager to monitor all comments taking place to see whether these are appropriate comments and to take appropriate action to resolve, rescind, or reopen comments that were closed in the past. And another critical tool, one of the main things that we often think about when we talk about quality control is checklists and forms. Now, there are a lot of checklists and forms available to us within the department, and almost every district has gone through developing their own checklists. Checklists are simple yet remarkably effective strategy for quality. The caution of checklists is often framed as, some people sometimes see it as more paperwork, or some people see it as cookbook engineering, when that's not really true. The key to avoid that perception is by continuously evolving checklists with lessons learned and updates and manuals and standards. Keeping all of those up to date is a critical part of keeping checklists effective. And you can see at the bottom, you basically have, existing checklists. You have to take into account lessons learned, updated criteria and standards, and your project-specific constraints. There are certain things on this project that are really going to constrain the project one way or another. All those that need to be looked at on the checklist need to be reviewed. Those are very critical things on this specific project that have to be reviewed. All those three things need to be taken into account to update your checklists for project-specific checklists. Okay, now moving on to phase submittals. As we spoke about earlier, the PPM outlines 3 critical areas to monitor in terms of quality control. And as we spoke, it's a good idea to kind of break up your QC plan into those three areas of initial engineering, final engineering design, update engineering design. But of course, you know, on a day-to-day basis, we often don't hear those terms. What we usually hear is phase submittals, phase 1, phase 2, phase 3, phase 4. And you can kind of see that just that quick, you know, initial engineering design essentially encompasses majority of your phase 1. Final engineering design is essentially your phase 2, 3, and 4. Obviously, there's a little bit of overlap. There's always a little bit of engineering design that continues into some of the other phases, but they essentially follow that alignment. And you can see here, figure 2.1, volume 2 of the PPM. It lists all the documents and that typically go into project plan set and the progression of those documents. And you can see on the right, kind of simplified that illustration for you. You can, starting at the bottom, you see plan sets that should start out at the very initial state of a project, from landscape plans, traffic control plans, going down to a typical section. That segment you see here at the bottom. These are all the inputs that typically start at the initiation of a project. And the elements that should be complete by phase 2 are typically your back of sidewalk profiles, your project control, your project layout, and your typical section. And then another key starting point is phase 1. You can see almost all other items start right after phase 1. And you can see almost all the plan sets are complete by phase 3, with the exception of contract time being incorporated at the very end. And another key thing you kind of see in this illustration is it really gives you a good message of the role that the phase 4 review plays. I mean, you can almost see majority of your documents should be complete by phase 3. As you see down here, complete but subject to change. And that really is the main reason we have the phase 4 submittal, to incorporate that level of quality control into those last minute changes. You know, and we'll kind of run through the phase submittals here. Phase 1, at this review stage, no decisions have been finalized, and there is an opportunity to change many aspects of the project. Phase 1 quality control involves safety and functionality of the design, establishing restraints to the project so that permits, right-of-way, easements, utility relocations are known and feasible for final engineering. Phase 2, at this review, the project layout, the primary function should be complete. You know, most restraints have been identified. Things like the permits, right-of-way easements, you are identifying what needed to be done. By phase 2, you might not have those complete, but you know what needs to be done at this stage. Most of the restraints have been identified, and the phase 2 quality control becomes more focused on the secondary functional details and ensuring the restraints identified are being addressed. You've gone from phase 1 identifying those things, such as permits, right-of-way, to now phase 2 where you're actually addressing them. And phase 3, all of those at this review, both primary functionality of the roadway and the secondary functionality, such as the drainage and the structural components, drainage, lighting, all these things should be complete. The phase 3 quality control becomes more focused on verifying that the restraints have been addressed. Phase 1, we identified those restraints. Phase 2, we identified how to address them. And phase 3 is really just about ensuring that they have been addressed and certified. This is typically when you'll receive your right-of-way, utility certification, environmental certification, and evaluating specs and quantities to ensure that the contractor can submit a competitive bid, really looking at the bidability of the project. Phase 4, as we said earlier in the previous slide, you know, this is really to assure all previous comments have been addressed. This is your final catch-all for any last-minute changes and to ensure all comments have been addressed. I have highlighted here Exhibit 13A of the PPM, which outlines the initial engineering process. And, on the right, Chapter 16 of the PPM, Volume 1, which talks about the design submittals that basically go into your initial engineering process. And kind of what I'm trying to, the message I'm trying to give you here with these red squares I have highlighted, is pretty much all of these items highlighted are essentially quality control. You kind of get a feeling, 5 of those steps, out of 14, 5 are quality control. And, taking all that back to that quality control model that we spoke about earlier, if you put that process into this, into that quality control model, you wind up with something kind of like this. Obviously, every project is a little bit different. Those black arrows that represent coordination, there'll be a little coordination and feedback. Those will be a little bit different in every project. But you get something kind of like this, your project scope, which has to go through its own quality control to make sure that it's complete and agreed to by all parties and accepted, which kind of leads to your environmental evaluation or reevaluation, which at the same time, your project scope coordinated with your typical section, criteria, design controls, design assumptions, and commitments. All of that also at the same time, your design survey, which leads up to your CAD work and beginning your analysis, which typically the output of that will take you to your preliminary geometric design, preliminary geotech, drainage, structures design, which takes you further to kind of the second preliminary level of your geometric design profiles, cross sections, intersections, and to your final geometric design. And likewise, there's QC feedback coordination taking place with that design and right-of-way requirements, and you can see that going back up to your typical section, which kind of goes back up to your environmental evaluation. And you kind of see how it's all coordinated, and there's a lot of back-to-back. A lot of things are dependent on each other, predecessors and successors, to a very high level during your phase 1 submittal. And here I have outlined, this is section 2.3.2.1 requirements for phase submittal in volume 2 of the PPM. This really gives you your overall framework of how checklists or QC review should be set up for phase 1 for initial engineering. Again, this is just the framework. There should obviously be more project-specific details that go into the project-specific QC plan and project-specific checklists. And likewise, final engineering. Now, one thing, likewise, I have, you can see about 3 out of the 9 steps in final engineering are essentially quality control that I have highlighted there. Now, one thing you can see is one way final engineering difference from initial is you saw work being performed in initial, then quality control step, then work being performed, then quality control. When you're in your final, you're basically, your first step here on the left is the work being performed and then going through quality control. And then you could say documenting and finalizing everything based on that quality control. So it comes to a little bit more of a simpler model, as we said so before. And here's kind of, if you take that and put it into, our QC model, you'll come out with something like this. As you might notice, more channels taking place than phase 1, than initial, but they're happening simultaneously. Everyone kind of at this stage knows what they need to do. They're able to work simultaneously. And you see the coordination is a lot more organized now, a lot more simplified, a lot more streamlined, as we said. And obviously taking you to your phase 2 submittal, review for constructability. By that time, your scope, agreements, resolutions, things like that should be complete, kind of comes off. And you notice it's starting to get simplified as we go down the line. And your phase 3 submittal, review for bidability, more for the contractuality of it, as we said. And as you can see, a lot of things start getting dropped that they should be complete and shouldn't have to be looked at again. Things like your utility agreements and your right-of-way. By that time, it should be complete. There should be no reason to revisit those items again. And your phase 4, which, as we said, was kind of a review to ensure phase 3 is complete and to catch any last-minute changes, which I kind of have labeled here a review for concurrence, which will take you to your design acceptance or final plans. And kind of, as I said earlier in the presentation, there should only have to be one iteration of quality control between your phase 4 and your design acceptance. And that's really the big benefit of incorporating a phase 4 review, is you now only have one iteration and you can go directly to your design acceptance. And this is the framework for phase 2. A lot more documents you got to look through. There's about 6 pages of guidance of the requirements for your phase 2 submittals. And obviously, because now you're going into a lot of the very technical details of each technical discipline, optional pipe material, voltage drop, a lot of very specific criteria that needs to be met. But again, these requirements should be the framework you use for your phase 2 review checklists and process. And phase 3 and phase 4, almost your checklists and process should be actually very similar to phase 2 in terms of the overall framework, but the focus is different. Phase 3 is about addressing phase 2 comments, but the same requirements, the same framework of the requirements still apply. But you're also looking at things like your estimates and quantities now, ensuring complete quantity calculations and things like traffic control items have a basis and follow the basis of estimates. You're looking to see not just your design and plans, but now you're looking to see certifications, those constraints we talked about, identifying them in phase 1, addressing them in phase 2. In phase 3, you're now looking to see if these things have been completed, verifying they're completed. And likewise for agreements, LFAs, JPAs, maintenance agreements, they were identified in phase 1, addressed in phase 2, and now you're checking, are they complete in phase 3? And then if you go through that process, you see how simplified phase 4 becomes. It's about addressing phase 3 comments and contract package completeness. And again, that's a big difference. Completeness is very different than quality. We'll try to talk about that a little bit more coming up. And FDOT, digital delivery. Okay, the Florida Administrative Code regarding digital delivery, all of our documents, we now require digital delivery of all documents. FDOT delivery process, all deliveries are to be submitted digitally as of July 1st, 2015. Phase 1, 2, and 3, signatures are not required. Specifications and technical special provision packages are required to be signed and sealed by the EOR. And to create digital image of the seal, there is a cell and microstation that uses the correct dimensions to create the seal. All these documents and references can be found on the production support webpage, and we have the link down there. As you can see, we're moving from quality to completeness. And that's kind of what this last stage of going to design acceptance is, going through these things which are more about completeness rather than quality. And now we'll try to talk a little bit more about that design acceptance. That design acceptance, again, the focus is no longer review for quality, but rather to review for completeness and plan processing. Some of the items, contract plans, local funding agreements, maintenance agreements, plans and specs, record sets, revisions, spec packages, That's not a comprehensive list. I just went through a couple of the major items there. The completed completed plans, specification package, and district estimate are shipped to central office for letting, or they're assembled and held in the district for district advertisement and letting. Again, as you can see, you're kind of going through a quick check to see if the package is complete before shipping it for letting. And this really is the framework of how we check to see if a project is complete. It's your contract file index. Everyone sees this come up at the end. Everyone's asking, where is the contract file index? Was that included in the submittal? And this really is the check to see if your project is complete, if you have a complete set of contract documents. And that kind of goes hand in hand with the preliminary engineering certification. The preliminary engineering certification is then kind of that certification we spoke about earlier, which now the design team is certifying that it is complete and that the project is ready to be shipped. So those two last levels, and you can find these documents in the PPM Volume 1. You can see the contract file index is Exhibit 20B, and the preliminary engineering certification is Exhibit 20D. And one other thing I wanted to talk to you about, successful strategies. While we were putting together this presentation, we kind of started to learn a few things. Everyone has a little bit different style. Some things they believe are very effective and have worked well for them in terms of quality control. You know, one is accelerated schedules, replacing milestones with meetings. You know, almost all districts have reported success of replacing the Phase 1 submittal with individual meetings or a QC process per discipline. You know, the Phase 1 is really about that initial technical design, where face-to-face meetings sometimes are more appropriate than you know, a mass ERC review with reviewers. So for simple projects, you know, 3R, safety, almost all districts, the department, I think we do this without thinking about it, of eliminating the Phase 1 submittal and replacing it with meetings. But some districts have also reported to us that they occasionally skip the Phase 4 submittal and replace it with a meeting. You know, obviously you can see how that benefits the target of the department is always looking for ways to accelerate schedules. And this is one of the strategies a lot of districts have reported they do in different ways and have kind of mastered how to still maintain quality by doing this. And one of the keys for that last one of that Phase 4 submittal that we do here in District 4 is we hold what's called a pre-production meeting. We've replaced that last check-all instead of having it with a mass number of reviewers, since it really is targeted at addressing the previous Phase 3 comments and making sure they're complete. We've replaced it with a meeting. The meeting is conducted between Final Plans Office and FDOT project managers and consultant designers on the project. It's held about 4 weeks prior to the production submittal to ensure there's time to do any of those really small changes and still meet the production submittal on time. You know, plans are prepared for the meeting, information about funding, updated changes, and any unresolved comments from the Phase 3. The tips that we spoke about for an effective meeting earlier, you know, have the information available, make sure that information is available to people, you know, and not just the final product information, but all information that went into it, you know, of certain commitments or unresolved items and why they are left unresolved. Make that aware to people at the meeting ahead of time. That's one of the tools that in District 4 and that we use, and we've seen other districts do it in a little bit different mechanism sometimes, but have found a way to replace the Phase 4 submittal with face-to-face meetings as being more effective. And kind of hand in hand with that is creating using the ERC comments as a form of certification. A lot of districts reported to us that they require certification from the FDOT-PM and the EOR that previous ERC comments have been addressed before allowing the next phase submittal or final acceptance. Some do this just at the last, just before final acceptance as part of that meeting of the Phase 4. Some do it at each phase submittal, at the phase 2 submittal to ensure phase 1 comments, at phase 3 to ensure phase 2 comments were addressed. And it's actually a very beneficial tool because, as we spoke earlier, a big investment went into developing these comments, these review comments. So it's very important to have them certified to get some confirmation that they have been addressed. Checklists. Checklists is a tool that's been reported by everyone. Everyone uses checklists. However, some tips we learned from our outreach, some districts indicated they hold regular lessons learned meetings, as we spoke about. Some do it internally in the department, and some hold consultant forums. They bring the consultant industry in for regular updates to critical checklists. Many districts emphasized using checklists as a tool for communication and training. They emphasized checklists should be written in a format that concentrates on teaching reviewers the best way to ID errors and how to use manuals, how to successfully convey comments. And this is kind of an interesting tip. This is one kind of we wished we had time to get into in more detail from some of the discussions we had with districts. They said they don't want people to get dependent on checklists, as we spoke about before. Some consider that cookbook engineering, but they see checklists as very beneficial as a training tool to get people up and running. And kind of shows you there's really an art to how you write a checklist, to how you write, even though the two checklists might have the same information that you're looking at, but one is written in a different way, and that can really, written more as a training, with a training message to it, can make it much more effective. Some districts have specific positions within their design office assigned for QC. These positions provide a centralized point of contact on quality, making it easier to maintain and reevaluate checklists and processes. That's actually very valuable. I see can probably make things a lot more streamlined if you have one focal point. People know who to go to get checklists updated, or sometimes even to serve as help resolve, a third party to help resolve QC comments. Title blocks, everybody sees title blocks. This is kind of a core standard within the industry, and this is a wonderful tool for, evolved from the days of doing paper reviews. It's still used in electronic reviews, but kind of it's been refined and evolved to a high level through many years of paper reviews. Practices repeated multiple times. It's title blocks on plan sheets that clearly define the designer, checker, and reviewer, as well as the EOR, QC manager sign-offs for when reviews are completed. And some districts mentioned they require consultants to submit their marked up QC plans with critical phase submittals to ensure that they are performing their internal quality control. And, I thought about that, and with the, how easy actually it is to scan documents to PDF these days, that actually is a very smart idea to have, scan documents of your marked up, the consultant's marked up set of plans submitted with submittals. That gives you a little bit extra assurance, a little bit extra certification that quality control was taking place. Individual meetings and combined meetings across disciplines. A lot of individual meetings are valuable in that they allow disciplines a chance to speak with the design team one-on-one without interruption and without deviating from the agenda. But combined meetings are also valuable. Some disciplines, sometimes you have to get them all together to understand an issue and to understand how to resolve it. Things like pavement design, construction, MOT. Sometimes you need all three parties in the room, or structures, roadway, and right-of-way. Sometimes you need all three parties. A lot of districts reported to us for certain types of projects, they schedule regular combined meetings. They make it required for certain types of combined meetings to take place for certain projects. And probably one of the biggest ones people have a lot of faith in is construction reviews. All districts discussed constructability reviews from key construction staff as part of their quality control. It is also very important to look at feedback during the construction process and information provided during post-construction reviews about making sure those lessons learned from construction are incorporated back Some districts have even created additional phase submittals only to construction in order to ensure comments have been implemented, and they use that as a mechanism to obtain certification from the Construction Cost Center. Just as we spoke about getting certification from the EOR and the FDOT-PM, you know, some districts keep construction in the game too and make sure they're certifying projects and testing certain things have been met. And, you know, I think one of the reasons constructability, construction reviews keeps playing a role is because, you know, nothing teaches us better than our own experience. And there's a lot of things that just can't get translated into checklists, that it requires experienced personnel who've been through it to really identify that item on a contract set of plans. And with that's kind of the end of our presentation. You know, a lot of those things we had there with successful strategies, you know, we learned a lot during this process. Wish we had more time to look into it in detail. But that's about all we have for today.